Hey Rock Buds, Rock Papa here. Hope you guys are doing great wherever you are. Today I thought we'd talk about the landscape that volcanoes create. We'll look at the process of a volcanic eruption, what comes first, what comes next usually, and then we'll also look at some of these phenomena such as hot springs and lahars, that sort of thing. We'll describe them and show you some rock examples of those different kinds of phenomena and the landscapes that these volcanoes create when they erupt. So stay tuned, and I hope you like this video, so please subscribe. Thanks a million to all you wonderful subscribers. So here we go. Volcanic landscapes. In this video, we're going to look at the three main types of volcanoes: stratovolcanoes, shield volcanoes, and cinder cone volcanoes. We'll also look at volcanic phenomena like steam explosions, lahars, pyroclastic flows, dacite domes, and hydrothermal areas. And the best place I know of where we can find all the volcano types and all of these mentioned volcanic phenomena is Mount Lassen Volcanic National Park in Northern California. Mount Lassen is located in the very southernmost portion of the Cascade Mountain Range. The Cascade Range is a mountain range of active volcanoes, including Mount St. Helens. And these volcanoes are produced by the subduction of the Pacific Ocean plate beneath the western edge of North America. Hey Rock Buds, Mount Lassen is one of my most favorite places. And so let's take a look at this beautiful and geologically interesting park. This map shows the general layout of the park. In the southwestern corner you have a visitor center. It's called the Kamyamani Visitor Center. That is a Navajo word that means good morning. In the northwest portion of the park, you have the Loomis Ranger Station and Visitor Center and Museum. And before we go on, let's just take a look at some of the beautiful photos of this place. And here's Mount Lassen, the largest of several stratovolcanoes located in the park. Hey guys, the Mount Lassen area has been erupting for the past 300,000 years, and Mount Lassen itself began to erupt off and on about 30,000 years ago. And we're going to focus on its most recent eruption and the results thereof. In late 1913, Mount Lassen began to produce intermittent earthquakes, and earthquakes are the very first sign that something big is about to happen with a stratovolcano. Then in 1914, Mount Lassen began to produce a series of small steam explosions. The second sign that something big is going to happen. Steam explosions happen when felsic magma rising up to the top of the volcano comes in contact with water, causing an explosion of steam and hot ash. After about 180 small steam explosions, in May 1915, Mount Lassen exploded with a massive steam explosion that blew tons of red-hot rock onto the mountainside and created an avalanche of mud, water, and hot molten rocks that flowed down the mountainside. This avalanche of mud, water, and hot rocks flowing down the mountainside along the major stream beds is called a lahar. Here's some pictures of lahar mud flows and lahar rock itself. A little later in 1915, the main event Mount Lassen explosion occurred that blasted hunks of rock of all sizes, including dust size, 30,000 feet into the air. A blanket of this red-hot rock and dust came avalanching down the mountain as a pyroclastic flow. At 400 miles an hour and 1,500 degrees Fahrenheit, it destroyed everything in its path, reaching 25 miles down the mountain. Here's a funky kind of drawing that'll give us a good idea about how a stratovolcano works. In this example, the stratovolcano is happening in the ocean, but the same process happens when the ocean crust is subducted beneath the continent edge, like the case with the Cascade Mountains. And of course, this is a generalized view of things to make it more simple to understand. You can see that we have three kinds of magma filling up the stratovolcano. At the top, we have light-colored felsic magma that would be made of rhyolite magma and granite magma. Lower down is the slightly heavier salt and pepper diorite magma that is intermediate in rock reaction. And then at the bottom, you have the dark, heavy, mafic gabbro magma. As the dark ocean crust continues to subduct beneath the continent, more and more magma is produced, and that magma breaks up into the three components, felsic, intermediate, and mafic. They rise to their specific locations based on their melting temperature and density. This whole process starts earthquakes going. As the whole magma blob begins to rise, the felsic magma comes in contact with water, and that creates the steam explosions that can result in the debris avalanches of mud, water, and rock called lahars. See all that white felsic magma at the top of the volcano? It's plugging the volcano. It does not want to flow out of the volcano because it's so high in quartz, and quartz bonds are super strong. Mount St. Helens shows us what happens next. A gigantic bulge rises higher and higher, maybe bulging out 5 feet a day until it can't hold the pressure anymore, and there's a massive explosion. The whole side of the mountain is blown off. Along with this, the felsic magma near the top of the volcano breaks out into dacite lava that blobs out like thick toothpaste. And on the lower flanks, the intermediate magma, diorite magma, bulges out and erupts as andesite lava, which flows a little bit more freely than the felsic lava. And then down toward the base, farther out from the center of the stratovolcano, you get the gabbro or mafic plutons erupting as basalt lava. The basalt lava has very little quartz in it, so it flows very freely, creating a shield volcano from which basalt lava flows radiate out, covering a lot of ground. Basaltic cinder cones also develop in these surrounding areas, and they're made of basalt lava that comes out with a tremendous amount of gas in it, and the gas blows the lava into small pieces called cinders, or also scoria. And near the volcano, as well as many miles away, especially downwind, you get ash falls. So here we've got a summary of the explosive and destructive phase of a stratovolcano. Okay, rock buds, now let's take a look at Mount Lassen to see what happens after all the eruptive phase is over. The black arrow points to Mount Lassen, the biggest of the several stratovolcanoes in Mount Lassen Park. It stands about 10,400 feet above sea level. And now it's called a dacite dome or a plug dome peak because its volcanic plumbing has been plugged by cooled dacite lava. As a matter of fact, Mount Lassen is the largest plug dome or dacite dome volcano in the world. And we're looking at some of this dacite plug, which is called Vulcan's Eye. South of Mount Lassen Peak and just north of the visitor center is the Bumpass Hell hydrothermal area. Water from snow and rain percolates down into the mountain where it comes in contact with the hot magma. The superheated water is able to dissolve all kinds of minerals and metals from the hot mineral-rich volcanic magmas that it brings up to the surface in these hydrothermal areas. Steam laden with hydrogen sulfide gas rises up from these areas, giving them the smell of rotten eggs. Boiling mud pots bubble like cauldrons. The mud bubbles pop, releasing scalding hot hydrogen sulfide gas. Below ground, the hot mineral-rich water flushes through piles of volcanic tuff and ash and other rocks, adding many interesting minerals and changing their composition. Here we have some quartz, muscovite, pyrite, sericite schist from rock formed in this way and then later metamorphosed. The reddish-purple color is iron pyrite that's been flushed into the rock, and the white is called sericite, which is formed from muscovite in a hot water environment. The reddish pyrite staining is what miners look for when they're hunting for gold and other precious metals. And the Mount Lassen area has produced its share of gold. Here are some pictures of some of the interesting rocks produced in these hydrothermal areas. Hot springs and hot springs resorts are a very pleasant landscape that volcanoes can produce. The arrow points to the Drakesbad Hot Springs Resort in Mount Lassen National Volcanic Park. The water in Hot Springs Creek is heated by the fires below and flows down into the Drakesbad Resort, where you can soak your weary bones in the warm, mineral-rich waters, for a fee, of course. Up here in the northeast corner of the park, we can find a shield volcano and a cinder cone. Shield volcanoes are found in outlying areas around the stratovolcano center, where gabbro magma at the bottom of the stratovolcano can find its way out along the sides as basalt lava flows. Here's a picture of the Mount Lassen basalt lava flow, which covers about 15 square miles. And these shield volcanoes eruptions are not violent because the basalt magma is thin and it flows out readily instead of blocking the volcanic vent like the felsic magma does. And the Mount Lassen cinder cone is located nearby. It's about 700 feet tall, and it happens when gas in the lava expands as it reaches the surface and blows the lava into little bits called cinders or scoria. And in this picture you can see the cinder cone and the lava flow in the background. Okay, rock buds, that's it for volcanic landscapes. I hope you like this. Thank you so much for watching, and if it was useful to you, please subscribe. And this is your Rock Papa saying happy rock hunting to all my most excellent rock buds. Papa out.